we are going to visualize how pass by reference works. So again, we have a set of registers allocated to a task main, and then we have another task foo. In this case, we are passing the pointer to x by reference. So here's what this means. When we call foo, we're not passing a copy of 4, we're passing the address, which in this case is the third tentacle. We are going to make an update. We're going to dereference x is equal to 4, and then we add 2 to 6, and then once we update that and pass the value back, it updates the copy in main, and we deallocate those registers and that instructions on the instruction stack. So now let's take a look at swap.c and see how this works. So what's going on is we have swap x and swap y. These are two registers. We're going to put over here, and I'm going to say sx for short and sy for swap y, like so. And we know now that this is 10 and 25. And we print these out, we now know that this will print out 10 and 25. And then in the reading, I indicated that if you want to pass by reference, you're not passing the value inside the register, you're passing the address. And we see this is done with ampersand swap x and ampersand swap y. And that's going to become pointer x and pointer y. So we create a new set of tasks, and we've done this with a new color. And I'm going to call this px and py. These are two registers. And the values inside of that is ampersand sx, or the address of sx, sy for the address of swap y. So that's how we have to make that call. And now we go into swap itself. So this is a new task. And the first thing that it does is it allocates its own local variable. Oops, a little smaller. So I'm going to allocate its own local variable. We'll call that TV for temp val. And here is the crucial aspect. Star pointer x. I'm going to indicate what's happening here in yellow. First, I go to pointer x, and I say, well, what's your value? Well, the value inside of it is ampersand sx for swap x. When I dereference it, it tells me to go to that location and get the value and then store it in this register. So now it comes down here, and this new value is 10. So next, let's go through star y is equal to pointer star x. This means that I start out again at pointer y, and I'm dereferencing. So I go to the address, and then I checked out that value. That's pointer y. Change colors here a little bit. So I'm going to take this and call this green. For star pointer x, we're going to do the same thing. We go to pointer x, and we have that data. So it means we're going to set this data on the left equal to this data on the right, which means 25 is now going to be the new value of sx. Change the color here, 25. So the value on the right now goes to the value on the left. The final line of code, I'll just update this to color, 25. The final line of code is star pointer y is equal to temp val. So again, what we do is we go to pointer y, points to the address of swap y, and we have to deal with the data there. And that's going to be equal to the data in this register, and that's going to be 10. So 10 comes up here, and what this means is that we dereference the swap y and we set this value equal to 10. So now let's compile and run our code and test our theory, because what we're expecting is that when we print this out, it's going to say swap x is equal to 25 and swap y is equal to 10. We go to our tabby, do swap, /swap for execution. Before it was 10 and 25, after it's 25 and 10, and we remove the executable to respect the server space.